Alright, so this is homework from the previous time. This is Techniques of Integration 3.5 was the chain rule. Yeah, it was the chain rule. Take a look at 37 and 41. I think I know what's going on there. Let's jam with it here. So number 37. So I have a function, and it looks like it's a rational function, so I know I'm going to use the chain rule at this point. There it is. Chain rule of use. And so just to remind ourselves here, the derivative of two functions on top of each other would be f over g would be the g function or the bottom function times the derivative of the top minus the top function derivative of the bottom function over the bottom function squared. So we're going to use that rule and we're going to go with it here. So let's go with it. So derivative of this function is, and we got ourselves the bottom function that's going to go in there. This guy here. And then we're going to take the derivative of the top. So in this case, it's a power function. So the 3 is going to go out in front. The inside is going to stay the same. Now it's to the second power. And then we're going to take the derivative of the inside. So that's going to be 2 here. That's going to be a 0. So just a multiplier of 2. Minus sign. Then we're going to bring down the top function as is, and let's take derivative of the bottom function this time. So that's going to be 8 out in front. The inside stays exactly the same, and it's going to go to the 7th power this time. And then we're going to take derivative of the inside, which would be 2 times 4, 8x. And there's your derivative of the bottom function. Then we're going to go with the bottom function being squared. So kind of careful here because it's the 8th power, and then we're going to square that still. Alright, something you should know about quotient rules is that most times you are going to have to cancel functions down. And so as we simplify this, most likely you will be canceling at least a few things here. So let's go with it here. So let's simplify first. This little top row right here, I got a 2 here, I got a 3 here, so I have a 6 in front. And so 6 in front, and then we can just write these. I'm going to put the 2x plus 3 first, and bring this one down. And there's my 8th minus sign. And then here, collecting all the multiples, 8 times 8x would be 64x. It'll be, well, I wrote down the bottom function this time. And then the top function right there to the 3rd power over, now I have to the 16th power. Alright, so now let's think about how we're going to simplify this here. So notice the bottom function is 4x squared minus 1. This is 4x squared minus 1 to the 8th. This is 4x squared minus 1 to the 7th. So I can get rid of 7 of these guys. So this guy's going to go away completely. I'm going to have 1 more of these over here. So that's going to go down to 1. And then this one's going to go down to 9 because we're getting rid of 4x squared minus 1 to the 7th power. So canceled to the 9th, and this is just going to be 1. So let's go with it. Let's see what we have here. So same thing, same rules apply. We're just canceling here, so we're just going to rewrite it. That's going to go 1 power now. Out of this term, the 4x squared minus 1 is gone completely, so we're just left with 64x, 2x minus 3 to the 2x plus 3 to the 3rd, and then this one's going to be to the 9th this time. Okay, now the question is this: can I simplify this? So notice I have a 2x plus 3 over here to the 2nd power, 2x plus 3 to the 3rd. So I can factor out a 2x plus 3 to the 2nd power out. And then 64 and 6, those guys just have a 2 in common. That's all they have, just a 2 in common. So let's factor out 2x plus 3 to the 2nd, and then also a 2. I'm losing space here, so let me go on to the next slide. Let's go with it here. So all on the outside. 2's pulled out. Oh, okay. I can put the bottom there. That's to the 9th. 2 is on the front side of things. 2x plus 3 to the second power is taken out. Remember, because if you have two terms that are exactly the same, you can only take out the lowest exponent term. Alright, then we're thinking what's left over? What's left over here? From the first term, looks like a 3 is left over from the 6. And then we have one of these that's still over here. So 4x squared minus 1. From the next term, 2 into 64 will be 32x. And then it'll be an extra one of these that's left over. So 2x plus 3. Alright, let me extend that out a little further. Okay, so now the whole piece here is just to simplify this as much as possible. So let's go with it here. So 3 times 4 is 12, so 12x squared. 3 times negative 1 would be a minus 3. Negative 32x times 2x would make a minus 64x squared. Negative 32x times 3 would be a minus 96x. Alright, and let's combine these guys together. So this guy and this guy combined together would give us a negative 52x squared. This guy comes down, minus 36x, and then a minus 3. Okay, so let's put these together. I think I know what was the issue on the homework itself was, as this guy gets written in from here. So notice inside that parenthesis, the second parenthesis, is all of them are negative items, right? They're all subtraction, they're all negative. And so what happens in mathematics is this is still correct, this is technically correct here, but just to make it look better, if you see every single piece here to be negatives, what you want to do is you just want to multiply out or take out a negative, just stick it out in front, and that would be the last of it right here. So it'd be a minus in front, so what we're doing is we're taking out a negative from here. And we have a 2x plus 3 to the second power, and then we have now a positive 52x squared plus 96x plus 3. Cool. All over that, and that is the end. There it is. We finally finished up. So these are taking quite a bit. I'm glad we left them for a video. Alright, 41 is the other one. And so this is fun. We're going to take a second derivative of this function here. So real quick here, just so we know, this guy is going to have to be a product rule. So look at your sheet and make sure you know how to do the product rule. Alright, and this one's going to be a chain rule, right? It's sine squared. So if you want to think about this here, you could think about this as just being like this. It's sine x to the second power. And then you use power rule and a chain rule inside it. Alright, let's go with it. Alright, and taking the first derivative. Let's go with first derivative here. So product rule in our hands. So I'm going to take the first function, write it down. Let me just kind of go exactly how the product rule states in the book here. So it's x. Then we're going to take, so the first function times the derivative of the second function. So derivative of cosine is negative sine. And inside is going to be a 5x still. And then that's a chain rule there. So that's going to be a 5 after that. Plus sign, because again we're still doing the product rule here. So then it's going to be a derivative, or the second function written down. And it's a derivative of the first function, which is derivative of x is 1. So there it is. We're done the product rule. So on to this one. This is just simple chain rule. So 2 goes on to the outside. Sine of x stays the same. Derivative of sine x is cosine x. Alright, I think I know what the issue is here. Alright, and then you can take derivative of x if you want. Derivative of x is 1, and kind of show it if you like. You don't really need to. That's extra. Alright, simplifying things out as much as we can here. So going all the way back to the first one here, I got a 5 over here, x over here. How about and then a negative sign. So how about a negative 5x? Sine of 5x goes next. Cool. Done. Next. Plus. Oh, that's easy. That's just cosine of 5x. Alright, and this one's going to be just a minus sign to sine x cosine x. Alright, and then here's the fun part here. If you guys remember from your trigonometry class, it was trig identities, this piece right here, just to make things a little easier. And the question, can you take this as using a product rule? Yes, you can, and it would be perfectly fine. The way the book uses it, and it's kind of good for you guys to remember because you guys will use it again in calculus. It should come up a few times in calculus. It should come up a few times in calculus, second semester calc. This little trigonometric rule, I think it was called, yeah, it was called the double angle formula for sine, if you think about it, double angle formula for sine. So as I do this here, this guy's going to be 2 sine of x cosine x is sine of 2x. That's the thing. Go back to your trig days or grab a trig book or look online. So look online if you want to look at double angle formula for sine function. Alright, what this does is it brings it down to one single function, a lot easier to work with, a lot easier to take derivatives of. So think back to your trig days, some of those trig functions are still useful. And let's go with it here. So after that, I think we can simplify things out. And again, this is only going to be the first derivative, right? This is not even started with the second derivative yet. So now you get to write down sine of 2x. Perfecto. Okay, and that's the end of the first derivative. Looks nice, looks clean. So now we're going to take the second derivative. So first derivative is given like this, and let's now move on. So second derivative, and again this is going to be a product rule here. So a product rule is kind of funny, right? You can take it doesn't matter if you take the first derivative times the second plus the first times the derivative of the second, or so I'm just gonna go with taking just like the quotient rule here. So I'm going to keep the second function exactly the same, take derivative of the first function. I'm going to name it as negative 5x, so the derivative is negative 5 plus, and then we're going to go with first function derivative of the second function here. So derivative of sine of 5x, this would be cosine 5x, and then after that would just be a derivative of 5x, which is 5, plus derivative of cosine of 5x would just be negative sine 5x times derivative of 5x. Keep on going. This is going to be a chain rule, so sine goes to cosine of 2x, and then barely fitting it in here, derivative of 2x is just 2 right there. Oof, okay, simplifying this out here, let's see, negative 5 sine of 5x. This is going to be negative 5x here and a 5 all the way over here. So putting those together, negative 25 cosine 5x. This one's going to be a 5 goes out in front, so negative 5 sine of 5x. And this one's going to be the 2 goes in front, so minus 2 cosine of 2x. Alright, with that, like terms, that's what we look for. Yes, I see this little guy here, that is, and this guy, those are like terms. They are both sine of 5x, so let's combine them together. I think the way the book writes it, it writes this one first, so let's write this one first. So negative 25x cosine 5x. Then let's combine these guys together. It goes down here, minus 10 sine of 5x, and then the last part here comes down, minus 2 cosine 2x. Alright, and we are done. There it is. We are done with 41 as well.